Alright guys, so in 8.2 we start drawing angles, okay, and what we're doing guys is we're building towards this thing called the unit circle and knowing how far from an initial side we have to go to draw an angle. So this first top right up here, you guys can read that on your own, but I'll just kind of go through the very important things from it. So as you can see, initial side is highlighted right here. Okay, the initial side of every single angle that we draw is going to be right here, so also known as our positive x-axis. Okay, so this is the initial side of every angle, which means this is the starting point. Okay, and then the ending point is called the terminal side, so this is where the angle would end. An angle is in standard position if its vertex is at the origin and its initial side lies on the positive x-axis. So we just talked about that. Okay, so these angles that we'll be drawing are all going to be angles in standard position. So it says draw an angle with the given measure in standard position. So we need to think about this. If we're always supposed to start on the positive x, that's going to tell us that this is 0 degrees. And then as we go around, we always go counterclockwise. So we go 90 degrees here, 180 degrees here, and then 270 degrees here. And then we could also put 360 degrees there. So if it's asking us for 200 degrees, we need to go, we'll start here, right? This is our initial side. And then our end side, if we're going to go 280 degrees, we need to go, or 200, we would go 180 degrees and then about 20 more. So then this angle that we just drew is 200 degrees. And then you add this little circle thing right here to denote that you're drawing an angle. Okay? All right, 110 degrees. So same idea, right? 180 is over here, 90 is up here. So we need to go 10 degrees past 90. So 20 degrees past 90 is probably right about here. So that's my terminal side, my initial side, and then the angle that we want, right? 110 degrees. We always draw this to denote where the angle is that we're talking about. And then this last one, negative 350 degrees. So now we're thinking the other direction. So if this is 0 degrees, this would be negative 90 degrees. This would be negative 180 degrees. This would be negative 270 degrees. So then to go 360, remember we started our terminal side here. And then if positive is counterclockwise, that means negative is clockwise. So then to go 350 degrees, well, we need to go almost 360, so we're just 10 degrees more than 360. And then this is where it's really important to draw that circle of where our angle is, right? So that's our negative 350 degree angle right there. All right, so that's drawing an angle in standard position. So coterminal angles are angles that have the same terminal side, or they end at the same point. So what you could think about is an angle, right? Say that our angle is 90 degrees. So if we went right here, this would be 90 degrees. A coterminal angle to 90 degrees would be an angle that ends at the same point. So we would start at the same point, so let's draw this angle, and then we would draw it here. But then what happens if we go this way? Now we're at negative 270 degrees. So these two things right here, 90 and negative 270, would be coterminal angles. The way to calculate a coterminal angle is you either add or subtract 360 degrees. Okay? Because if we take 90 and we subtract it off 360, that would give us negative 270 degrees. Right, so that's just a little example. So number 2, it says find angles, one positive, one negative, that are coterminal with the given angle. So 230 degrees. So if we want one positive one, we're just going to go bigger. So 230 plus 360. The reason we picked 360 because this is a full circle. So then that's going to be 590 degrees would be our positive one. And then we take 230, we subtract off 360, right? So that's going to be negative, and then 130 degrees. Right, 3 minus 2 is 1, 6 minus 3 is 0. Yeah, negative 130. So these would be our two answers here. All right, And let's go negative 65 degrees. So we go negative 65 degrees and we add 360 to it. That's going to give us what? 295 degrees, right? And then we go negative 65 degrees and we subtract 360 from it. That's going to give us negative 425 degrees. All right. Last little bit of this information, guys, is reference angles, okay? So what is a reference angle? It's the acute angle that an angle in standard position makes with the x-axis. So take a look at these examples here, right? So our angle in standard position is right here. So then the reference angle is the acute angle of our reference angle, or of our standard angle. So the way you can think about this, guys, is what is the fastest way to get back to the x-axis, right? So if we have, how do I close that? Okay, so if we have an angle that comes around like this, the reference angle, what the heck does that keep opening up for? The reference angle is the fastest way to get back to the x-axis if our angle opens up like this. So let's come down here. Find the reference angles for the following, right? So we go here. I like to draw these ones out if I'm not given a drawing. So 90 degrees, okay? So then 115 is going to be 25 past 90 degrees, right? So this is our 115 degrees. So then what we are looking for is this reference angle right here, right? So then the quickest way to get there is to know, well, what is this distance right here? That's 25 degrees. If we went all the way, this would be 180 degrees. So then if we just took, or just kidding, what you need to think about is this, right? This is 90 degrees. We already have 25 of it. So then 90 minus 25. That gives us 65 degrees. Okay? Awesome. The other way to look at that one, guys, is you could do, I believe, is 180 minus 115, right? Because the 180 degree is the closest x value, is the closest degree to get to an x-axis. And if you subtract 115, that would give us 5 here, and then that would be a 7. 7 minus 1 is 6. 1 minus 1 is 5. Okay, so that's another way to find that reference angle. This way makes more sense to me, though, right? We have a 90 degree angle. We went 25 degrees past 90, so then 90 minus 25. All right, let's take a look at the next one. 258. Okay, so I'm going to draw my picture because it helps me. 270 is here. 180 is here. So 258, right? So 258, I'm thinking is going to be in this direction. Right, we subtracted off 2, so this is 12 degrees that we had to subtract off. So then we would just take 90, right, because this is a 90 degree angle, and we subtract off 12, and that's going to give us 78 degrees, would be the reference angle, right? And then the way you look at that is, well, 258, how much past 180 is that? So 258 minus 180, right, that should give us 78 degrees. So that's the other way to do that. All right, 340. So we have the drawing. 360 is here. 340 is 20 degrees this way. So then when we draw this, we have 90 degrees here. So 90 minus 20 is 70 degrees. Or you can think of it the other way, right? We have 360 degrees, and we want to subtract off 340 degrees from that, right? And then that would tell us, or not 340, sorry. Right, 340 puts us here. And then we want to know the distance of the 70 degrees. Why can I not think of how to do that one right now? All right. So we click that. Oh yeah, to do this one, you would have to think of 270 degrees here, and then you'd have to go 340 minus 270. That gives us our 70 degrees. Okay, so like I said, I very much like that way more. It makes more sense to me. But if this other way, right, 340 minus the 270 makes more sense to you, by all means do that way as well. And then the last one here, okay, so we have 50 degrees, so 50 degrees, so we have 90. We go 40 less than 50, puts us about here. That's 40 degrees that way, so then 90 minus 40 is going to give us 50 degrees, right? Oh, well, me, dingus over here, right, 50 degrees is this, so then the reference angle clearly is also just 50 degrees. Okay, so that one is much easier than we could have made it. You could have just wrote 50 degrees down and been done. All right. Anyway, that is the notes for today, guys. Hopefully they were short and kind of sweet. If you have any questions, as always, please come to office hours and let me know.